So welcome everybody. I hope you enjoyed lunch. So I will be talking about some, not war stories, but some tales about maintaining a library, which is mostly the Liberator library, which I created, and with the help of a lot of other people, I released it, and it's, I guess, used in the wild. So that's the motivation for my talk, actually. Yes, as I told you, I'm the creator and maintainer of Liberator. There are other people helping me, but most of the work is done by me. I released it to the public in 2009. I would not have expected anybody to use it. Until now, it's just 320 commits, which doesn't sound too much, but you can actually create quite some mess. So the problem is, people are really using it. And suddenly you are responsible. And whoops, changing stuff might break other people's code. So I'm not longer free to do what I consider to be the best way to do it. So when I change stuff, users need to keep up with the changes. When I change the API, the users need to change their code. Maybe it's running in production and have a bug fix, and at the same time I change the API, and this prevents people from using the bug fix because they need to change their implementation on production on a Saturday evening or whatever. So yeah, it gives some headaches to the maintainer, and that's how it looks when people chasing your API changes, actually. So changing the API actually will break other people's code. So in the background, you can see this Apple charging connector, which actually changed, and then people need to create some adapters to be able to use the old stuff with the new stuff and all this. So, and in the end, I find myself like suffering from bad early decisions because I could not change the API anymore. So I got some pull requests and I got some issues, and as you can see, this is not too much compared to whatever core async or Clojure script, but when you're like the single maintainer, it's quite some work that you need to get done. And well, it escalated quickly. So why is this actually bad? Why can't we simply change the API? So I already said people are using it, and you bring some like back pressure to other people's code. But another thing to consider is when you cannot change the interface, then you cannot provide the best access to the features of your library. And users actually overlook features. They cannot like use all the power of your library. And eventually they reinvent features. So in the background, you're seeing like an egg cracking device, while you could simply use like a sharp edge or the back of a knife. But if you don't know that you can use a knife to crack open an egg, then people are becoming very creative and stimulating creativity in users. Well, while in general it might be a good idea, in some cases it isn't. So stimulating creativity is undesired. And then people are starting to create workarounds. It's very natural. We all do this all the time. Like we have whatever update in Clojure core, update function. Recently, we have one. So people are starting to write update a lot of time, or a function to map over the values of just the map a function just over the values of a map. So what's the problem with workarounds? So most of the time they are undocumented. So somewhere in some utility namespace in your typical project, there are all the workarounds, or they're like on the spot of where you need it, and nobody understands of your coworkers actually understands why it is done like that. So it's hidden knowledge, and it promotes kind of cargo culting. So you do it that way because someone like a year ago found out that it doesn't work in any other way. And eventually, at some point, the workarounds will become obsolete because the library updates and ships with that feature or provides an alternative and maybe better way to do it. And in the end, as a library maintainer, it increases the burden of backward compatibility. For every workaround that users use in the wild and which is maybe promoted over Google Groups or the Slack chat, so you need to do it like that, I must pay attention to that when I change the library, not only what I have documented work, but also like the common workarounds still work. So it increases my workload. So what users also are doing is like wrapping your libraries. So it's in the sense of, I like what the library can do, but I don't like the interface to it. And sometimes it's necessary. When we want to make use of a Java library, for example, it makes sense to provide a Clojure interface which is more like idiomatic Clojure code instead of using this dot notation and all that. And we have also problems with that, because when the upstream library changes and adds new features, our wrapper code falls behind and maybe doesn't offer like a nice Clojure interface to that feature, and you find yourself in a situation where you have like code which for some part uses the nice Clojure wrapper functions, and the other part goes into the dirty details of Java interop. So you might not want that. And actually, the effect is that the wrapper code hides new features, or maybe hides existing features because nobody implemented the wrapping for that particular part of the library. So then people are something I call shoehorning. So in the background, you see a Philips bit. But as I learned by someone whose name I will not reveal, you can actually use it to drill holes in your walls. Well, it's a kind of like gentle violence against your API. But there's also square pegging. I don't know. I remember this advertisement for this, about this boy who was very successful. So you see, it works. You can put the round peg into the square hole. And I guess from your co-workers, you know that expression, right? After being successfully abusing a library, because they know that you are going to maintain this. And then there's something I made up all those expressions, so don't try to Google that in the Urban Dictionary or like that. So there are also something I call phantom bugs, which are bugs which actually, well, aren't bugs. For example, the API encouraged the user to make simple mistakes, which are hard to find. And this is a case of miscommunication. So you as a library maintainer fail to document the features in the interface in a way that empowers the user to actually use the library in a correct way and to use it in a fail-safe way. So for example, I order 500 meters of a cable, and I get delivered 500 feet of cable, and a lot of curses being exchanged over the Atlantic Ocean. We had that at the NASA, I guess. And this is a typical case of miscommunication where something in the documentation went wrong. And there's our doc string. So I will show you a typical example of a doc string in the wild. And then there's error handling. We had a very nice talk earlier today. I've yet to see a library, including my own libraries, where I can say, yes, error handling is sufficiently and excessively documented, so that I, as the user of the library, know what kind of thing happens in case of things go wrong. So my recommendation is to use a dedicated error handling model. For example, exceptions or special return values or error state. So we all saw that earlier today. Whatever model you choose, document it. The most easy model might be to throw an exception, some kind of like fail early or yes, some way to fail early and document the case that in every case, when something goes wrong, you will have an exception that you need to catch. Maybe wrap it into something like xinfo or use a special exception wrapper to enable the users to catch exceptions raised from somewhere in your library. And the other thing is, please be consistent. So I've seen libraries which, for some cases, throw exceptions. For the other case, you have to check a return value, and maybe they have even like a third way to do it. In the end, error handling is part of the application interface. So now comes like the embarrassing part with actual code examples. So it's I would show samples like of short-sighted interface design in the white, starring my code, and yeah, we have some guest appearance. By other people's code, it's like fully anonymized due to like legal issues. So that's one case of failures, like I call like too many knobs. So when your application interface has too many knobs, people are hesitating to use it and are being scared of by the waste number of choice. So for example, this is part of the Liberator documentation showing you all the keywords you can specify for callbacks. So I had to make sure it doesn't even fit on that screen. So my screen is a little taller. So it makes the users have a hard time to find out what to actually do. So which buttons must I press to make this library work in a way that I want it to work? On the other case, Liberator has not so many doc strings. So one of the key interfaces to the library is the resource function. And as you can see, well, there's no doc string at all. And even the function signature is a little bit of, well, not very suggestive. So just reading the interface, this is the API on a code level. You would not be able to make sense what to put into this whatever KVS vector or arguments. And this leads to something that I called before phantom bugs. So I don't know how many people have actually used Liberator here. So quite a few. So who finds the error? So don't be ashamed. I run into that every other day when I'm using Liberator. No, not so often, but quite a few times. So there's missing a question mark after exists. And that's why the interface to this resource, or the def resource function, in the end is this kind of like destructured map. And you can put in any keyword you like. And if it happens that you write exists without a question mark instead of exists with a question mark, the definition is silently ignored. And now, due to some unfortunate decisions in the first place, there's no way to make this validate, because it's by design that you can put arbitrary keyword arguments into the resource definition for your implementation code to make use of them. So no way to validate that, at least for Liberator to change that to validate, except maybe adding some additional function or definition like you add an option, please validate the definition, and this rules out that you use custom keywords. The next problem I see a lot of times regarding APIs is the case of incomposability. So, for example, those Lego bricks compose very well. When they were invented, I guess, somewhere in the 60s or 70s, nobody would imagine that like 40 or 50 years later, the same Lego bricks, I have those old ones too, would still match the modern ones. That's a good thing. And then we have this variadic map arguments, like with Liberator. Well, they don't compose too well. So, for example, let's assume we're building some kinds of database access layer, and we have a function load entity and has like a reasonable function signature. You pass in some kind of database handle as the first argument, and then like a arbitrary string of options as a map being destructured. And it looks very fine, and it has like a nice interface, very suggestive keyword names like whatever lazy loading or whatever use eager fetching or throw in an error or automatically reconnect in case of disconnection, whatever. And then we see in our code that we are respecifying the same arguments all over the time. And of course, we want to avoid unnecessary duplication of code, and we define some default options. Looks fine so far. And now we try to apply that to the load entity function, and we find ourselves trying to apply the values. We have those default options, and we extend them, for example, with a query definition, and then we apply that to load entity, and whoa, it doesn't work. Because the last argument in the apply function call is a map. And when you apply a map, it will be converted into a sequence, and the sequence will be not like a list like keyword value, but it will be a list of vectors containing the keyword and the value, and another vector containing another keyword and another value. Actually can work around that, but it doesn't look too nice. So you have apply load entity, whatever it might be, apply concat, and then the merged value. You don't want to have your users do that. So apply concat, apply function, you can use the threading operator to do something like that, but really? I don't know if that's a very suggestive interface for the user. I don't think so. And then there are macros. Well, macros are nice and fine, and one of the key features of Clojure and Lisp in general, but they're kind of a trap, so kind of a trap door, because once you're in macro land, you need to stay in macro land. So when you go on the meta level of programming, you find yourself somewhere there, and there's no easy way to return to the typical function application. You're no longer expressing your function calls, but you're expressing your code on a higher level. And one of the symptoms is that there's no macro apply, as far as I know, in Clojure core. So when you have a macro like def resource, which is a very convenient macro, you can define a top-level variable named foo. This is also a liberator construct, and you can define all the callbacks afterwards. But in this case also, we want to maybe apply some defaults to all our resources. For example, they exist only in every other case on average. There's no easy way to apply those defaults to your concrete macro or macro calls. So when you try that, which I guess every Clojure beginner has experienced, so apply the macro and all the arguments, I get a very nice suggestive error, which, well, it's pretty good for Clojure exception, right? You can take value of a macro, and even the macro name is mentioned. This actually prevents reuse and promotes code duplication, or even worse, people doing all kind of magic stuff, wrapping macros with macros with macros. So in this case, Liberator had to extend the API and find a backward compatible way to do it, because we have all those code running in the wild, and they didn't want to change this core API or the signature of this core macro in a way that people have to do an upgrade or a major breaking upgrade. So Liberator does one thing. It introduced an optional map as the first argument. So in case the first argument to the def resource call is, or in this case, the second argument, the first one for def resource is the name, but the second one, if it's like a map, in this case defaults, then all the other values get merged into it. And so my suggestion is better stay away from macros. So macros are pretty convenient when it goes to those definition macros. You see that with testing frameworks, with database access libraries that people are providing those definition macros. But to be honest, this doesn't buy you too much, because those definition macros decompose into the definition of a variable on the actual thing that creates the value which is bound to the variable. And you can do that your own, or maybe even write a macro your own when you need it, but always provide a way to do without macros. So that's what the call above actually like macro expands to, plus minus some details. So as you can see, we have a simple function invocation, the resource function. And when we define that, we kind of land up where we land when you do the def resource call. And actually, we can drop the functionality to handle this special case of the first argument to resource is a map by merging ourselves. And this is another case I often encounter in the wild. It's a kind of incomplete API. As I guess we all encountered that before, that we have a nice function, a nice library, it has all kinds of functions, and suddenly one piece is missing, which we consider be kind of a key part of the functionality. For example, this might not even be something completely missing, but unhandled edge cases. And this is surprising to the user and leads to workarounds. And we saw before that workarounds, well, they have their drawbacks. And also it can lead to the fact that users of your library spend times searching for a particular functionality which isn't there because they think they might not know the name, or the name of the function might be a different one, and so they lose time just to learn after hours that the functionality they were looking for simply doesn't exist. And those workarounds, we also have an example from Liberator. This is what you would expect how an expression somewhere in your callback function looks like. For those not too familiar with Liberator, so there's a call to ring response, which allows you to return like a literal ring response map, which is not touched by Liberator anymore. And as the first argument, you can, in general, return a value which is then converted to the actual representation depending on the content type, for example, to JSON, to maybe a text string, or to whatever you define. And as the second argument, it accepts like a partial ring response, which is then merged with the actual response. But I don't need to understand that to understand my point here, because what you really need to do is the following. And this is quite sophisticated and not very suggestive, and I guess people need to learn that from some documentation, and this is nothing you will find typically in your random doc string, right? Another point is that Clojure users expect nil punning. That means when you have somewhere a value of nil and continue to work with that, well, things work and you end up with a nil value. So that's a pretty common idiom in Clojure and for a lot of functions. But what I saw in the wild is something like that, which looks like a very innocent print function which should dump some data structure, maybe in the end in your log file. And people with a Java background, I see often to use toString on the data. And all works fine until your staff value is nil. And you have this nice suggestive Clojure exception, reflector.java, line 301. I never heard of that before until I prepared for the talk, so I never looked into the details. Another case of like an incomplete API is missing error handling. So the default might be that your library or the library you use simply throws an exception. And for Liberator, this meant that the users presented a nice HTTP status 500 internal server error. While this is semantically correct, it's not very helpful, at least to the application developer. So since a particular revision, there's a possibility in Liberator to specify an exception handler. This has all kinds of drawbacks on its own, especially when your exception handler throws an exception too. We had that also before with, I guess, Slingshot or the exception handling, error handling talk, what happens when you throw kind of recursive exceptions. But it's better than simply throw an exception and have the user, the application developer, to make sense of that. And then we come to state. So this is a hot topic in Clojure, right? You might ask, is state part of the API? And I would say yes, it is state is part of the API. Because when you call functions in your library which expect some particular state to be of some particular reference or handle or whatever immutable thing to be in a particular state, you must document that. And what I see in the wild is a lot of atoms, for example. An atom's whole state, and they have, you have code, which I saw. We have like a system state with a single atom, and then comes another developer, and because nobody thought about how to integrate that into the API, like on a higher level in bigger systems, we have another atom, of course, with another state. And because we also already have two atoms, developers feel like that's the right way to do. And you have some kind of auxiliary state. And finally, you have a state manager, somewhere in a state manager state atom, and all that. And finally, yet another state. There are some problems with that, of course. There's no coordination between atoms, so you cannot have like a transaction over multiple atoms in a, well, accessible way. And the functions you call, when they accept some state, they are no longer referentially transparent, which means when you call the function twice with the same arguments, you might end up with having different outcome because the state changes. This is necessary, of course, because all the computation we do has some side effects. Without side effects, we wouldn't have anything like printed on the screen or changed in the database. So it makes sense that Clojure provides abstractions to change state, of course. But as soon as your library or your API has this concept of state, things become complicated. And there are functions that expect some kind of initialization. And this is also problematic because you cannot simply call the function, provide the arguments. You need to know that before doing this, you have to do that, and you make sure that the initialization step actually was successful. It could be that there was an error, and this is silently thrown somewhere in a core async thread or like that, and then you wonder why things no longer work. So my recommendation in this case is to use explicit arguments as far as you can go, and use a single atom to hold all the system state. So we had this before in the Omnext talk, right? David Nolan is a proposal of that on the client. It's not possible in every case, but you need to make sure that when you use multiple atoms, there's no simple way of coordination. And in the end, I would recommend not to pass the actual state atom, but a value, and then in the end, make your function return another value. So I have an example, small example, with, well, a smaller version of all those state things. And in this case, we're using a single atom holding a map pointing to the actual state. And in this case, all those update in, assoc in, remove in, or what is called a dissoc in functions are your friend. And this is how a random function somewhere from a system could look like. The idea is that the start interest function starts some system, and for the other functions to know, you need to update some state. And well, it gets past the state as an argument, not the atom, but the actual state, and some random arguments, for example, a file to ingest, and then it starts a random whatever background process to actually process the file. And after that, it assocs in system state, ingest status, the value that this is running. So that's not actual production safe code because all things could go wrong here. There's no error handling. But what you can see is that in the end, you can use a swap over the actual state atom, and you only have one atom, and provide that the start ingest function and the file parameter. And this should make the developers, or this should make it easier to reason about what happens in the system. It's easier to test. And, for example, you can use multiple functions. When you have top-level atoms, there's only like one instance of this atom, so you cannot have like multiple ingests run at the same time. When you pass around state explicitly and pass around maybe even the atoms holding the state, you could instantiate the same like component multiple times. These are things you need to consider when you build an API. Another way to do this is to use dynamic binding, also a topic we saw earlier today. So, we define. Oh, we're missing the default value, I guess. So we define the dynamic variable db, for example, and provide some helper function with db, which actually boils down to a binding call. And then we have this fetch from db, whatever function. This is like typical code we see a lot in Clojure. And this is nice because we can avoid, for example, the endless passing of parameters or of handles. Like you have a top-level database handle to Cassandra or to a file or to whatever. And when you go down the implementation stack, you need to pass it around a lot. For example, you have a low-level exec function, which actually does an SQL request to the database. You might have a fetch function, which is responsible to query. And this actually calls exec. And you have a load user function, which does all the user loading. And this actually delegates to fetch. And you have like an authorize function, as an example, which tries to load a user. And what you can see is that you have to pass this db entry all the way down. In this case, it looks very natural, but in the wild, it might be become complicated when you have multiple systems, multiple databases, bigger systems, like systems where you're processing data coming from one system into another system. You might have a handle for some kind of error reporting. You want to do metrics, doing different things. So you're passing all those stuff around. Well, that's kind of ugly. But there's a problem with dynamic binding. What if you want to connect to more than one database? There's no way. When you can bind the dynamic variable only to one value at a time. So when you offer that, please at least offer a non-binding interface to it somehow too. Unless you can make sure it doesn't make sense to have more than one database, for example. But I don't know if I, as a library maintainer, want to make that decision for my users. So how do we fix that? So this is more like a general recommendations. I suggest out-of-band documentation. Out-of-band documentation for me is not what you write into a doc string on a function level. Maybe it's a doc string on a namespace level, but when you have a bigger library, all your code might be split over multiple namespace, so please provide some kind of like top-level documentation for your library. And in this documentation, explain the design motivation. Why is the library providing an interface like it is? There might be some reason, I hope. So after the talk, you might think more about the API. And so write it down. Why do you suppose or suggest or use like dynamic binding of a variable? Why do you not offer to use multiple databases at once with your library? There might be a reason. Explain the model and the abstractions. In the not trivial libraries, we have some kind of data structures. We have like a technical or mental model behind it. So, for example, core async used this notion of a channel. What is a channel? You need to document that. Else people were just like copy and pasting other people's code and try to make things work somehow. So there's a to-do. I don't know why. So Liberator uses the ring interface, for example. This is a very simple but powerful abstraction for web requests. Every HTTP request comes in as a map. There's a request method, which is get, for example, and some header values. OK, there's maybe a body for post, but that's how a request looks like. Very powerful and simple encoding. And as when you implement a ring request handler, you need to provide a response, which is also a very simple map, having the status code, a random body value, and some HTTP headers. And the actual function is a function which takes a request and returns a response. That's very easy. Another abstraction in Liberator is that it holds some kind of processing state. So Liberator does a big decision tree, and you provide callbacks, and of course, somehow, during the processing of the request, you need to keep track of the values of the outcome of the execution of those callback functions. And this is the context. So it looks like this. So there might be an HTTP status, which is already determined by Liberator. There's the original HTTP request, a representation, resource, whatever, even custom keys in it. And every decision function looks like that. It accepts the context, the current context, does something fancy, and in the end, it returns a context update, which is typically a map, which is then like merged into the original context. That's the way how you update the results while Liberator processes the web request. And this is actually documented. So there's a section, see in the background, on the GitHub pages and the Liberator documentation about the execution model. And this is important because it's not something that you easily can learn from doc strings or maybe from examples. Especially, what are you allowed to return as a context or not? OK, so may applaud here that I have done this nice documentation. Also, Liberator provides a high-level view on what's going on. So as I already told, there's this kind of decision tree. And when you never used Liberator before, it might be very like hidden and unintuitive for you. So we have like this kind of documentation in the docs, a big graph, and actually there's some kind of a debug console where you have this highlighted, the path that your request actually took. This is all part, for me, of the API, because this is what the developer develops against. What can you do to work around this too many ops problem? You can use protocols. So this is something that could be used for Liberator. Instead of relying on those keywords, which you can easily get wrong, use a protocol, which even have like doc strings. Or you can use something I call microprotocols. Yada, which is another HTTP REST server library, does this. You have, like in this case, 4 protocols which have like a single method, which you need to implement. Is not too easy to get that wrong. So when you have those, the protocol names are checked by the compiler, and the protocol implementation function names are also checked by the compiler, and you get better error responses. Omnext, for example, does this too, small protocols. So to wrap it up, API design is about users, not the user sitting in front of the computer like the end users or the consumer, but the developers which use your library. You need to plan ahead. I released Liberator to the public, and suddenly, yes, people were using it, and I had a bad time because I did not plan ahead. And I still think about how could I do things right, and maybe there will be some kind of Liberator 2 at some point which breaks all compatibility, but I never do that step because I have so much to do to maintain backwards compatibility right now. Find the right abstraction. When you provide the right model to the API, it makes it easier for the user to actually make sense of all the things. When you, whatever process numeric values, find the right abstraction for those values. When you're doing web requests, find the right abstraction. For example, the ring model is very powerful. So it's the right abstraction, I guess. But also you need to think about convenience for the user, developer on the one side, and expressiveness on the other side. So when something as a library is convenient, you might assume a lot of things like default values or what to do in case of error. And this goes against expressiveness. You're taking control from the user to make it more convenient. I guess in general there's a middle ground you have to find. So my recommendation as an API designer, forget everything. Take the user's perspective, assume nothing, and look how far do you get only, for example, reading the doc strings. This is hard because you know the library so well and you know how to do it. But try to be like a new user of your library, or actually find a new user of a library, maybe a coworker, and make him or her write down what's wrong and where are like the bad pieces of your API. And then observe the users. Look what they're doing. How are they using your library? For example, search on GitHub. You will be surprised what people are doing to Liberator. And when you get those works as designed issues, which you close with that reason, ask for context and motivation to understand why the user thinks it should work differently. Thank you.